Good day to everyone and also Dr. Noraini Hamza. My name is Chong Wei An. Today I will present about the project proposal entitled Development of an IoT-based smart waste segregation and recycling system for the residential communities in Malaysia. This project falls under the topic for waste management. In Malaysia, it is currently facing the challenges of managing the solid waste. According to the reports of Malaysia Waste Management, Malaysia currently generates approximately 39,000 tons of solid waste every day. A significant portion of the waste is disposed into the landfills. Despite the ongoing recycling events, the recycling participation among the residential communities still remain very low. The existing waste collection system are also strongly relies on the fixed collection schedules rather than the actual waste producers. As a result, the collection vehicles may visit to the bin that are not full, but the other bins already exceed their capacity and overflow. In order to address these issues, this project proposes an IoT-based smart waste management solution which is consisting of smart recycling bins, ultrasonic sensors, ESP32 microcontrollers, cloud databases, monitoring dashboards, and also the mobile applications. Next is the problem statement. Firstly is the environmental problem. The increasing of the waste generation may cause the overcrowded landfill, environmental pollution, and greenhouse gas emissions such as methane and carbon dioxide. Secondly is the operational problem. The current collection system use the fixed schedules and lack of real-time monitoring capabilities. This had led to the overflowing waste bins, inefficient collection routes, and high fuel consumption. Thirdly is the social problem. Now many households still dispose the recyclable materials together with other general waste. This has resulted in the poor waste segregation, low recycling participation, and limited public awareness regarding the sustainable waste management. The first objective of this project is to design and develop an IoT enabled smart waste monitoring system using sensors, ESP32 microcontrollers, wireless communication technologies, and cloud database. The second objective is to develop a mobile application and dashboard to enable residents, waste truck operators, and local authorities to monitor the waste levels and recycling activities. The third objective is to improve the waste collection efficiency by reducing the unnecessary waste collection trips at least 20% through the real-time monitoring. This project scope includes the smart recycling bins, sensor integration, cloud infrastructure, dashboard development, mobile application development, system testing, and pilot deployment. The next slide is the smart waste segregation platform system. This system provides several key features. Firstly, it supports the real-time waste monitoring through the ultrasonic sensors installed inside the recycling bins. Secondly is the system that automatically alerts when the bin capacity reaches to the set limit. Thirdly is the residents can participate in the reward-based recycling program. The fourth is the real-time data, which allow the waste truck operators to optimize their schedules and collection rules. After collecting all the information, it can be analyzed through the dashboards and cloud-based system to support the data-driven decision makings. Next is the system architecture. The smart recycling bins is installed with an ultrasonic sensors that continuously measures the waste level inside the bins. The sensor sends the information to the ESP32 microcontroller for the processing. The ESP32 then transmits data through the Wi-Fi or GSM communication networks to a cloud database. The cloud database will then store the data and synchronize all the system components. And then the information are then accessed through a mobile application and monitoring dashboards by the residents, waste operators, and also the local authorities. So there are several engineering calculations were conducted. Firstly, the smart recycling bin was designed with a cylindrical geometry which has a radius of 0.35 meter and a height of 1 meter. It has a total capacity 385 liters. Once the bin reaches to the 80% capacity or equivalent to the 308 liters of waste, it will send a notification to alert all the parties. The next is the battery sizing calculations that has shown the minimum required is 9 ampere hour. So 10 ampere hour lithium batteries is sufficient to support the daily operation. The next is the solar panel calculations, which indicate that 25 recharge is sufficient for the solar panel under the Malaysian weather conditions. The next calculations is for the power consumption, communication latency, and waste collection optimizations. They indicate that the system can generate notification within 6 seconds and reduce the unnecessary collection trips up to 30%. The work breakdown structure WBS is proposed to ensure the effective project execution. The project is divided into the 7 major phases, which are project initiation, project planning, system design, system development, system testing, deployment, and also the project closure. Each phase contains their specific activities and contribute to the completion of the project. So the WBS is very critical to define the project scope, assign the responsibilities, and facilitate the monitoring. This is the project network sequence. The project begins with the initiation and planning activities, followed by the hardware design and software design. Both designs are conducted concurrently to reduce the project duration. The smart bin, mobile application, and dashboard deployment are then conducted in parallel. After that, all the system components are integrated, tested, deployed, and hand over to the stakeholders. The critical path analysis identified that there are two critical paths which has the similar total duration of 17 weeks. This project has estimated the budget is approximately 65,000 ringgit Malaysia. The highest costs are allocated to the smart recycling bin fabrication, IoT hardware components, and software development because these three are the main core infrastructure of the systems. The project team consists of the project manager, IoT engineers, software developers, quality assurance engineers, community engagement coordinators, and technicians. All of the positions plays their roles to ensure the successful planning, development, testing, deployment, and the all the activities. Several project risks were identified and analyzed. The highest risks include the sensor failure and development delays because they directly affect the system performance and the project progress. Additional risks include the user residence, budget overruns, data breaches, and internet failure. In order to mitigate these risks, it is required to implement the preventive maintenance schedules, project monitoring, awareness campaigns, and backup communication methods. These projects provide the benefits in the four major fields. The environmental benefits include the increased recycling participation, reduced landfill dependency, lower greenhouse gas emission, and so on. The economy benefits include the reduced operational costs, lower fuel consumption, and improved resource utilization. The social benefits include the increased environmental awareness, improved community participation, greener living environments, and so on. The technological benefits include the adoption of IoT technologies, support for smart city initiatives, and improve the data-driven decision making. In addition, this project is related to the two Sustainable Development Goals, which are SDG 11 and SDG 12. The SDG 11 is the Sustainable Cities and Communities. This project improves the urban cleanness, enhance the waste monitoring capabilities, and support the smart city initiatives. Meanwhile, the SDG 12 is the responsible consumption and production. The system encourages the waste segregation, improve the recycling participation, reduce the landfill dependency, and also promotes the circular economy practices. In conclusion, the waste management is still a significant challenge in Malaysia in terms of the environmental and operational topics. This project proposed the IoT-based smart waste segregation and recycling system that can integrate the smart recycling bins, IoT technology, cloud computing, mobile application, and monitoring the dashboards. So the proposed solution can improve the collection efficiency, such as the waste segregation, enhances the recycling participation, and also reduce the unnecessary waste collection trips. Furthermore, the project support the sustainability aligns with the Malaysia City Initiatives and also the SDG. I strongly believe that implementation of this system stated in this project can contribute to create a cleaner, smarter, and more sustainable residential communities. So that's all from me. Thank you for your attention.